So this is a continuation of the video programs we've been putting out for the Mini Cooper, 1960 Mini Cooper that I've been calling the Carbon Fiber Mini, which is kind of a half-truth because we've mixed carbon fiber and a lot of steel into this project. But in this particular segment, we're going to talk about suspension, and I've asked my friend Damian Hardy to join us and to share a little bit of his knowledge of suspension and the suggestions and contributions he's made towards the project. So without any further delay, Damian Hardy.
Hello. So the original Mini has trailing arms at the rear and a McPherson strut at the front. It's a really compact little arrangement that suits the package of the Mini quite well. Obviously, Charles didn't want to do that. He wants to do something significantly more exciting. And so at the rear end, we've got this very interesting arrangement with these two shocks here and these arms. And when both wheels go up and down, we exercise this spring and this damper. And when one wheel goes up and one wheel goes down, we exercise this spring and this damper. And normally, you wish you had more roll stiffness than you have heave stiffness. And so you end up adding things like anti-roll bars, and that's great, but you can't add any damping, and so you end up losing control of the roll motion. So this little linkage here is really good for adding some damping into the roll motion and being able to control it independently. So I think it'll be quite a nice setup tweak. The other thing we're doing, because the engine is now no longer sideways in the engine bay, is we've got room to put in some upper arms as well, and so we're going for a short and long arm double wishbone, as English people call it, suspension both ends, and I'm setting up the geometry there to try and keep the roll centers nice and low to give us good grip and nice and balanced front to rear to give us a predictable and understandable behavior for the car.
So I want to interrupt Damian and have us go down a little bit of a different road and come back as to why everything that he just said was super exciting for me to hear and why I got really fired up to put his suggestions into this car. So I come from a road race background, and I used to think the lowest possible car is the best and low center of gravity and get everything down, and then he's been slowly encouraging me to come up a little bit off the ground and more travel and listen to what he's saying because of his background. So go ahead and tell us a little bit about your background. What have you done in road cars and or other cars that would lead me to be that excited about this program?
So I'm even older than I look, and I've worked on all sorts of different things, and among the most interesting things I've worked on are World Rally cars, both the Subaru World Rally cars driven by people like Petra Solberg, and the Mini World Rally cars driven by Chris Meek and Danny Sordo. And Rally's really interesting because it's not these beautiful smooth surfaces that people are used to running on racetracks. And on a racetrack, you can just keep going lower and lower, and the centre of gravity gets lower and lower, and you keep getting a benefit from that. But on a rally stage, there's quite a lot of lumps and bumps, and if you lower the car too much, it ends up jumping off the bumps. And so some of the work that I did on the World Rally cars led me to conclude that if you're 10 millimetres too high, it costs you about 1/10 of a second per kilometre. But if you're 10 millimetres too low, it ends up costing you 7/10 of a second per kilometre because you lose time by skipping off all the bumps. And maybe that takes you offline, maybe it just reduces the braking grip that's available to you. And in an unpredictable environment, that makes the driver very cautious. So it's really important to have enough travel to match the surface that you're traveling on and using the vehicle on. And so if you're not only running on race circuits, then a bit more height is a really good thing. And that's why road cars typically sit higher than track cars.
So that being said, there's a few things that he talked about in this rear suspension that are kind of cool. What we're going to do with the car, as we've said in other videos, is its front engine, we're going to run a drive shaft, and we're going to run an independent rear end in the back. This entire assembly is going to sit what would you call that area just behind the rear window?
A parcel shelf, as we'd say in English. A parcel shelf, I think you'll find.
Okay, so that's a new one for me. This is going to sit on the parcel shelf, so there won't be any parcels in the rear window anymore.
Good Lord, what?
Yes. So what happens is there's going to be two rods that'll continue this line down to the axle, or ultimately the spindle, and we'll be able to control. We could have more travel in the wheel and less travel in here because it's on a rocker arm. And maybe you could explain to people a little bit about what a rocker arm is and does there.
Yeah, so the rocker arm is just, it's kind of like a seesaw. So this point here, you don't call them a seesaw, do you? You call them, what do you call them? A teeter-totter? What,
Yes,
the
right.
thing that two children sit on. Good Lord, all these strange words. This point here is fixed to the vehicle. And so the whole thing rotates around this point. So you can see if you push up on this point, basically these points have to move that way. And that's how you can take this motion, which comes from the hub, upper rod from the hub, and turn it into a motion that energizes the spring. And this kind of inboard suspension arrangement is quite common on quite a few circuit cars because it gets all this stuff out of the airflow. And so it's very appealing on a lot of circuit cars to particularly open wheel cars, to bring this stuff inboard and get it out of the airflow. But it also, even in a vehicle like this, it's kind of helpful because it means you can just reach right into the parcel shelf. Parcel shelf, I shall coach you on your pronunciation shortly. You can just reach right into the parcel shelf and make some adjustments, and you don't have to be down under the car, so it can be pretty convenient, as well as being visually quite amusing and sort of a talking point. There's a minor disadvantage that it's some weight that's a little bit higher than it needs to be, but overall everything in life is a balance between advantages and disadvantages, and given that the point of the vehicle is to kind of to talk about and to have fun with, then that small disadvantage seems worthwhile, I think.
Yeah, and then I did my best to make up for that weight by making the rocker arms out of carbon fiber plate, and the springs are out of titanium, and the shock's a pretty lightweight package. But nonetheless, it is the subject again of pros versus cons and practicality, and a good subject to talk about. So in addition to this one effort that we have sitting here about the rear suspension, front suspension, you've got spindles in front of you there, both front and rear to some degree. Maybe if you could just kind of guide us in the generic sense to say what's important. You talk a lot about trail in the front suspension, and you might even have something to say about trail on the back suspension. So independent rear end is, again, what this car is.
Yeah, so the upright here, this is a kind of a practice fabrication, I guess. I'm hoping that the real thing won't be just sort of fully plated like this.
We plan on adding holes to that and gussets and taking a bunch of weight out, but that has all the pickup points.
Yes. This piece here is the big sticky out bit that the wheel goes onto, and the wheel turns round this point without getting too technical about it. There's some machine features here that the inner race of the bearing sits on, and that gives us good geometric control of the location of the wheel. These points here are the two pickup points for the lateral arms that come out, the double wishbones. And the first thing you'll notice is that they're not in a vertical line. They're staggered. One goes more that way and one goes more that way. And that means that the axis that the wheel steers around is not vertical. And I care about that a lot. Anyone who knows me will know that I repeatedly say trail fixes everything. And what I mean by trail is if you draw a line through these points and then take it down to the ground, it's not at the center of the wheel, it's ahead of the center of the wheel. And what that means is that if for whatever reason, if we're looking down on the wheel and the vehicle is trying to move that way, well, the point that it turns about is slightly ahead of the wheel, and so a little bit like a shopping trolley wheel, it just moves itself into that direction. And the reason that we care about that is if you're driving a car and the rear end of the car starts to move, as the car moves sideways, this caster effect pulls the wheel in your hand, and it gives you a really quick, clean message about what's happening at the back of the car. And so trail gives you this tremendous steering feel and connection to the state of the vehicle. So I'm kind of obsessed with it. It was very important to have lots and lots of it on the World Rally cars because they had four-wheel drive, and so the front drive torque messes with the steering feel. But you could always win because you could always just put more trail on. But even without drive torques, this trail makes for a very clean steering feel. And if you study some of the cars that, for me anyway, have got the best steering feel, some of the BMW M cars and the Porsche 911s, you'll find they've got a good dose of trail on them. And so I always want to bake that into any front suspension layout that I make. The rear suspension, if you've made it right, it doesn't steer. And so the idea of trail is kind of, it's not really there. But the things that you make, they're never fully rigid, and so there's always a little bit of flexibility. And what you want is for that flexibility to help you in the car and not hinder you. And that basically means that when you look down on the car and you look at the back wheels, when you're going around a corner, you want this flexibility to turn the wheel slightly into the corner and not slightly out of the corner. Because if it turns the wheel slightly out of the corner, then the car is destabilized and the car feels a little bit alive at the back, and the driver's just got to pay some extra attention managing the back of the car. If it turns a little bit into the corner, and we're only talking tiny amounts here, maybe half a degree is quite a big event, but just the structural flexibility of everything is enough to move things around like that. That is the thing that can make the back of the car feel very dependable and makes the driver really trust the back of the car. Until you use some gas pedal and then move the back of the car, but that's okay because that's connected to what the driver wants to do. So we're trying to get this this idea that the car will do everything the driver wants and nothing the driver doesn't want, and that's why some of these details are important. And that's why I was obsessed with arranging the spindles on the rear axle the other way round to the front axle, and then we can tune the
Other way around, meaning the opposite direction of trail.
Yeah, so it looks like they've got anti-trail, but they haven't really got either, because the wheel shouldn't move. They've just got a sort of a flexibility.
It's not turning. Yeah, they're just going through the range of motion.
Yeah.
So let me change subjects here for a minute and then talk with you in front of the camera here about the general sense of suspension. We've had discussions over several beers about the idea of should the car be 3 inches off the ground, 4 inches off the ground? Should we focus all the weight down low? Should it be in the center of the car? Polar moments, things like that. And so I realized that there probably isn't a right answer for any of this, which is why it became good beer conversation.
Yeah.
We would sit there and bat the ball back and forth about what would some of the benefits be. The Mini Cooper is such a small car, and many people have taken their stab at trying to figure out how to make the most out of something that was already really, really cool.
Yeah.
But this is a little bit of a, I don't know, I guess my ego wants to say a different direction. And with that different direction, we've made enough changes along the way that we've really deviated from anything that it might have resembled in the beginning. So we just have to think very short wheelbase car. We've got a super wide tire and wheel package, almost a 10-inch tire on all four corners, the same, running at basically a square setup. And then, how do you think this car might behave given what we've done, and why have you, all joking aside, steered me in some directions versus another based on this beer chat?
So there's always a load of different questions when you're trying to set up a car, and it's good to understand where you can and can't decouple some of those questions. So the vertical question is really about the terrain that you're going to run it on. And so in terms of the height of the car, it's just important to understand where you're going to run it. And if you're going to run it somewhere smooth, run it low. If you're going to run it somewhere bumpier, you want to run it just high enough that it's not running out of travel. On the rally cars, we used to say, maybe once or twice per kilometre it should run out of travel. But it shouldn't be doing it 5 times a kilometre or 10 times a kilometre, because that's wasting time. If it never does it, maybe the car was too high. If it doesn't do it at all during the whole 20 kilometre stage, maybe the car was too high. And so we get the drivers' feedback on because they could sense very well when it was running out of travel. So that's the kind of the height question. And then there's a whole load of other questions about where is the weight in the car, how spread out it is, and how nimble is the car and how manageable is the car. Having a little car gives you a colossal advantage to start with, because it means every little bit that you turn the steering wheels rotates the car a lot, and the longer the car gets, the less true that is. So that makes the car really nimble and agile. The downside is that you might want nimble and agile at 30 or 40 or 50 miles an hour, but perhaps at 120 miles an hour, perhaps you're less concerned about nimble and agile. And so that's where some of these kind of games with the steering feel comes in, and particularly with a lot of trail, it's very good at holding the car on centre, and it weights the steering up, so that you have a kind of feeling of security for straight line running. So that's a kind of an important feature, if you like, of such a little car. And then the other question is this, where should the weight be? And every so often I come across people who say we should crowd all the weight into the middle of the car. And depending on who they are and what the circumstances are, I'll say, good luck with that. I'll watch. Or I'll say, actually, I really kind of don't think that you should do that. And basically, when you crowd the weight into the middle of the car,
Give us an example of a car that's currently made that might be designed somewhat like that perhaps people have driven.
So I think these days people have kind of got the hang of it. So I can't think of any sort of current.
In my mind, a Porsche
cars.
911 used to be like this. It seemed like the weight was very centered, and if you drove it and you got a little out of line, then it would come around on you on a moment's notice like a top. But maybe they've changed that a little bit.
So 911s, because they've got all the weight at the back, they have a kind of a different problem to this one that I'm talking about. I can come back to that. But this, when people are trying to crowd the weight into the middle, I'm thinking of cars like a Toyota MR2 or something like that. And they're very interesting because everyone starts off very enthusiastic and they do all this stuff where they put the weight in the middle of the car. And then they quite quickly find that the car is very nimble as you turn it in, but then quite difficult to catch. And so if you're loaded up mid-corner and there's some little disturbance on the road, you end up having to work really quite hard to manage the rotation of the vehicle in response to what seem like quite small disturbances. And so then what people do is they end up messing with the suspension, and they put some bump steer in, and they put this camber in, and this damping change, and anti-roll bars, and they do all this stuff that in the end subtracts from all that work they did to put the weight in the middle, to return the car back to a sweet spot. And if we had
To being drivable.
Yeah, if we had a kind of a robot driver with an infinite capacity, then sure, that it would just get better as you put the weight into the middle. But we haven't got robot drivers. We've got monkeys like me who've got a very finite capability and a very finite bandwidth in terms of understanding the motion of the car and being able to move our hands and so on. And so there's nothing special about the World Championship rally drivers in terms of how fast their arms move or anything. They're very practiced at seeing the patterns of the motion of the car, but really we're all the same. None of us can turn the wheel at more than about 1,000 degrees a second, and we can't do that for more than about 200 degrees of rotation because our arms get in the way of each other. So there's only kind of so much that you can do. So you end up having to, I'll say, dull the performance of the car a little bit to put it back inside the box that the human can manage. And then the human can be confident that the car's not going to bite, which in turn encourages the human to push right to the edge of the envelope. And so by making a worse car, you end up making a faster car because the person will carry it right to the grip limit mid-corner. And of course mid-corner speed is what gives you stage time and lap time. It's the thing to chase always. So this layout of the front engine, the north-south engine, and all this kind of chunky stuff, spreading the weight out in the car, even though the car is quite short, I think it'll still make it quite friendly. So you've got this sort of benefit of a small car that turns very readily, per angle of the steering wheel, but by spreading the weight out in it, it'll be less tricky at high speed. That's my prediction anyway. We'll see when you actually get it together.
Well, yeah, and so the good news for me is that Damien's giving me all this great information to work with, and then I need to translate that into what I'm capable of doing, and then produce a result, and then look at him and say, well, that's what you meant, right?
It's working all right so far.
Yeah, right, okay. Okay, so I've brought in a piece of somewhat funniness to the story that I'm not sure Damien necessarily agrees with when it comes to turning and making quick movements and whatnot. But I really love the fact that the British cars have integrated wood into many aspects of the car. And so as you watch the different videos, I've put wood together. And I made this carbon fiber wheel. We're in the process of cleaning it up and clear coating it in its final stages. And I really just grabbed it off the table here and decided to talk to Damien about it for a moment. So the funny thing is, I used to race midgets and did a little bit in a sprint car, and here in the United States, midgets and sprint cars are tons of fun, and everybody teases about driving them like a tractor because they've got this big, huge wheel here. So I made this wheel, and it's got this huge diameter, and yet at the same time, I really want this Mini Cooper to have a very dynamic, quick steering, kind of like a go-kart would have. So if it really comes down to this has slowed the steering too much, then it'll have a quick release and we can put a smaller wheel on for more competitive, spirited driving. But what do you think will happen? Do you think we could actually make the car quick steering and still have kind of a funny wheel like this? Do you see any benefit to the joke, or do you think it'll just be looks only?
I want to say there's certainly a visual aspect to it that some people will definitely react to. So minis are quite well known, the sort of traditional Isogonis Mini. They're quite well known for having a kind of a slightly strange steering wheel angle. You know, they're not at kind of this angle that people want. They're also known for having a steering wheel that's approximately this diameter, so that you hold onto it like this. So
aftermarket, wouldn't you say?
Yeah.
Because it seems like the ones that were original, every picture I've seen, it's a pretty big steering wheel.
Yeah, and of course, when you had manual steering, even on a car as light as the original Mini, a big rim helps reduce the forces, particularly when you're parking. The inertia of the wheel actually plays a surprising part in the system. So this effect that I talked about with the trail, where the car wants to turn the wheels into the direction of travel, because of the ratio in the steering gear, every degree that the car wants to move the road wheels, it moves this 10 degrees or 15 degrees or 20 degrees, you know, it depends on the kind of the ratio that you put in. But the inertia of this gets multiplied by the square of that ratio. So if the steering is 10-1, the inertia becomes 100 compared to what the rack is seeing. And so actually the inertia of the wheel can have a surprising effect on the behavior of the car.
On the feel of it, ultimately.
Yeah, and if you, basically, if the wheel's got too much inertia, it actually feels like the car is sluggish to turn. And particularly as it rotates, it feels like you've got to work very hard to catch the car. If the wheel's got too little inertia, that is a thing that can happen as well. What you find is as soon as the car starts to move, the steering over responds and the car ends up going kind of oscillatory. And so there's a flick steer test that some people do where they kind of just flick the wheel and let go and watch what happens to the car. That is definitely not something to try at home.
Not while you're driving.
Do not do that on the public road, because most cars react very, very badly to it. And I actually hate it as a test, because I don't really know what it tells me, other than this kind of like inertia match between the wheel and the rest of the system. But it is noticeable when you get it right, the car becomes very instinctive to drift, because the wheel moves at just the pace the whole car wants to move it with. And you can experiment, if you have a nice light rim, if you had a kind of a placeholder without the wood, you can just kind of strap tyre weights onto it with a bit of duct tape and stuff. And you can find the weight that feels good. But anyway, I think that'll be interesting. Be ready for some experimentation.
Yeah. Well, that's the deal here. Ultimately, this project is trying different things and experimenting, and we'll see how it goes. So that's it for this suspension video. Damian Hardy, thank you very much for coming and contributing, and I'm going to continue to lean on you to help me to the end. And see you next time.